In doing calculations for the vapor and dry air calculations, what we want to be able to do is have an approximation for the enthalpy. And what we'll do now is take a look at that. So this is an approximation, and we are able to do it because we're looking at temperatures in the range, like I mentioned before, between minus 10 degrees C and 50 degrees C. So what we'll begin with is look at the dry air. And if you recall, we said that enthalpy can be calculated using this equation here. Sometimes CCP changes if you have variable specific heats, but what we want to do is we want to integrate that. And so what we'll do is we'll integrate between 0 degrees Celsius and up to some arbitrary temperature not yet determined. That will be part of our calculation. And I'm going to pull the specific heat out because we're dealing with relatively small temperature changes. So we can take an average value for the specific heat. And we get that equation there. If we integrate now notice I'm dealing with degrees C here, not Kelvin. So you got to be a little careful when you're dealing with HVAC. It's different than what we looked at before. And the other thing we're going to say is we're going to assume 0 degrees C as being the reference state. And what that implies is the enthalpy at 0 degrees C we'll say is equal to 0. And so when we do that, we can simplify this equation. Notably, this term is going to go away. And what we end up with is the enthalpy of dry air now notice the units degrees C, kilojoules per kilogram degrees C, multiplied by temperature also in degrees C. So that is something a little different from what we've seen before. And consequently, we can then evaluate the change of enthalpy of dry air as 1.005 delta T. And the units of that would then be kilojoules per kilogram. So that's an approximation that we will be making for dry air. Let's proceed on and take a look at how we can deal with the water vapor. So for water vapor, we don't want to have to go into the steam tables every time we want to determine the enthalpy of water vapor. So we make an approximation here as well. And what that approximation is for a given temperature, we will assume that the enthalpy is equivalent to the saturated vapor enthalpy value at that particular temperature. And if you look in your book, it would vary from book to book, but the value of Hg can be approximated with this equation here, and this is again in degrees C, and the units of this are kilojoules per kilogram. Now, just be a little careful. Your book may use a slightly different value than this first term here. But it probably won't change by a significant amount, but just refer to the value that might have in your book because it might be slightly different than what I have here. But these are two approximate equations that we can then use to calculate enthalpy of the water vapor and the one previously, this was enthalpy of our dry air. And it's kind of a quick way of doing the calculations, but that's what we do a lot of with the HVAC. So that is how to treat enthalpy as an approximation.